In this video, we will be completing the Lesson 8 Bootstrap World packet. So starting off, it says go to this web address and examine the code that Luigi's Pizza Shop uses to determine how much to charge a customer. What we're going to be doing is we're going to be clicking Run, and in the Interactions window, we are going to evaluate cost cheese, cost broccoli, and cost mushrooms. So let's take a look at the code. I've opened up the Luigi's Pizza file where we see that there's already some code written in the definitions window. We are asked to click Run, and in the Interactions window, evaluate cost cheese, where we get 9 as an output. So go ahead and write that down. Also, cost broccoli evaluates to 10.25, and cost mushrooms evaluates to a string that says that's not on the menu. So go ahead and jot those 3 things down, and let's keep going. Let's take a look at number 2 in the packet. Complete the contract, purpose statement, and examples for the following word problem. So this is a word problem for a function called cost. Directions. Luigi's Pizza has hired you as a programmer. They offer the following pizza toppings: pepperoni for $10.50, cheese for $9, chicken for $11.25, and broccoli for $10.25. Write a function called cost that takes in the name of a topping and outputs the cost of a pizza with that topping. So first things first, we need our function name, which they tell us is cost. The domain, it says the function takes in the name of a topping. Is that a number, a string, an image, or a Boolean? That's going to be a string. And the output, or the range, it says it outputs the cost of a pizza with that topping. Is cost number, string, image, or Boolean? Cost is going to be a number. The price of something is a number. What does the function do? In my own words, I'm going to say that based on the word problem, this function produces the cost of a pizza with a chosen topping. Whatever topping was chosen as the input. When we take a look at our example section, we actually find that instead of only 2 examples like we've seen in past design recipes, we actually have 4 examples. So the reason we need 4 examples is because there's 4 choices for the toppings according to the word problem. So let's take a look at our first example. Our first example says when cost pepperoni is typed in, what should the function produce? Well, we know that it should produce the cost of a pizza with pepperoni on it. In the word problem up at the top, it says it's $10.50. So I'm just going to write that as 10.5 because putting that extra 0 in there is not necessary for the computer to understand what I mean. Our second example should be cost and another topping. So let's do cost cheese. And the function should produce the cost of a cheese pizza, which is $9. Go ahead and pause the video now and try the last 2 examples on your own. Here are our last 2 examples, so check those. And let's take a look at the bottom of this page. If we circle the changeable parts of the examples above and then come up with a variable name, we find that there are how many changeable parts, and then what are their names. So when we circle the changeable parts, first of all, I see that the input can change. The input is actually representing the topping on the pizza. So that's the first changeable part of this code. And secondly, the output is also changeable, which would be considered, let's say, the price. So we find that there are 2 changeable parts, the topping and the price. But here is why we needed to do this example. This is something we haven't seen before. Since the domain of the function only has 1 input, we cannot have 2 variables. So the 1 input is shown up here in the contract where I see that the domain is only 1 string. So we cannot have 2 variables. So we need a way to deal with this. So let's take a look at the next page. Since the price, which is the output, depends entirely on the topping, which is the input, then the price is what we call the dependent variable, and the topping is called the independent variable. So the price depends on the topping that's chosen, but the chosen topping does not depend on the price. The cost function makes use of special language feature called conditionals. The abbreviation for conditional is COND. So what I want to point out is that back in our Luigi's Pizza code, we see that COND, that conditional phrase, in our definition. This whole thing right here that I've just highlighted is our definition for this function. This COND, this conditional, is needed, and what we see below it are 5 lines of code that start and end with square brackets. So in our notes, in number 7, it says each conditional has at least one clause. That's a new vocabulary word for us now that we're working with conditionals. So each clause has a Boolean question and answer. Square brackets enclose the question and answer for each clause. In the cost function, there is one clause for cheese, another for pepperoni, and so on. If the question evaluates to true, the expression gets evaluated and returned. If the question is false, the computer will skip to the next clause. The last clause in a conditional can be what's called an else clause, which gets evaluated if all the questions before it are false. Looking at our function, that means that if people don't order pepperoni, cheese, chicken, or broccoli, then we can program the computer to charge a set amount. How much do you think Luigi should charge if someone orders a topping that's not on the menu? So we can get creative here. We can actually use any number. If someone comes in and wants peppers on their pizza, how much should they be charged, considering it's not on the menu? Let's say 20 bucks. So I want to point out here how these clauses work. The first clause is actually asking a question. Is the chosen topping cheese? If yes, produce $9 as the output. If no, or if false, move on to the next clause. Next clause, is the chosen topping pepperoni? If yes, produce $10.50 as the output. If no, move on to the next clause. Is chicken the chosen topping? If yes, produce this output. If no, move on to the next clause. Is broccoli the chosen topping? If yes, produce this output. If no, move on to the last clause. Everything else, all other possibilities, fall into this clause, fall into this category, in which case this function will produce the phrase, that's not on the menu. In our example, when we get to our definition, our else clause is actually going to be charging the customer $20 as opposed to telling them that it's not on the menu. So let's define the cost function. We've already done the contract, purpose statement, and 4 examples, but now it's time to define. So the function name is cost, and the variable we know is topping. So when cost with a topping gets typed in, we know we need a conditional. The first condition is if the chosen string for the topping is pepperoni, then $10.50 should be the output. If the chosen string for the topping is cheese, then the output should be 9, and so on. Go ahead and pause the video now, and using the first 2 clauses as an example, go ahead and do the next 2 clauses on your own. Pause now. Here's what the next 2 clauses should look like for chicken and broccoli. So here's the thing, if all of those clauses, all 4 of those clauses are false, we need a fallback. We need a clause that incorporates everything else. That's where our else clause comes in. So everything else, the output should be $20. That's for any topping that's ordered that's not on the menu. So what we find is we've actually just written this definition here. The order might be a little bit different, but instead of our else clause saying that's not on the menu, it actually is going to be 20. So now when I click run and the computer reads my new definition, now when a customer orders something that's on the menu, for example, cost broccoli, it'll give the price. But if someone orders something like mushrooms that's not on the menu, it'll charge $20. One other thing that this Luigi's Pizza code does is if we take the semicolons away from this last line of code where it says start cost and click run, it's actually an interactive cash register where I can type in what the topping ordered is and it'll give me the cost. So this is a simple way to simulate a cash register. Let's go. Number 9, look at the cost definition above. How many clauses are there for the cost function? Remember, the clauses are the statements that start and end with square brackets. So there are 5 clauses in this definition. There are 5. Identify the question in the first clause. Basically, I just want you to make sure you're understanding that the first clause is asking, is the chosen topping pepperoni? If the answer is yes, the output will be 1050, but if the answer is no, it moves on to the second clause. Identify the question in the second clause. Is the chosen topping cheese? If yes, give 9 as the output. If no, move on to the next clause, and so on. So that's how a conditional works with clauses. Let's take a look at the next page. Functions that use conditions are called piecewise functions. Why are piecewise functions so useful? This is where we're relating this to our video game. Think about the player in your game. You'd like the player to move one way if you press up, another way if you press down, another way if you press right, and another way if you press left. Those are really 4 separate conditions. Without conditionals, you could only write a function that always moves the player up, always moves it down, always left, always right, but not a combination of these movements. So in number 11, let's just quickly recap. Now that we know how to use conditionals, let's begin writing the code for update player, which we're actually going to be putting in our video game. When the arrow keys are pressed, the player will move 20 pixels in the appropriate direction. So I'm telling you that the character will move 20 pixels at a time. When the up key is pressed, what should happen to the player's coordinate? We've gone over this multiple times throughout our lessons. When up is pressed, X stays the same and Y increases by 20. We add 20 to the Y when we press up. How about down? X will stay the same when we press down, but Y will decrease by 20. When right and left are pressed, this time X is the one that's increasing or decreasing. Right, X will increase by 20, and Y will stay the same. And left, X decrease by 20, Y stays the same. So what we're going to be using in our video game is a function called makePosition, which is spelled like this, that the computer already knows. So just like the computer knows all of these functions here already, the computer also knows makePosition already. So the makePosition function tells the computer to make the position a certain place on the screen. For example, if we typed makePosition 300, 140, the computer would move the object to the point 300, 140 on the screen. To move the point 300, 140 to the right 20 pixels, we would type, this is where we have to use our makePosition function. We would make the position. When we move right, we have to change the X coordinate by adding 20. So I would add 20 to the 300, and I would keep the Y the same. I would keep the 140 the same. So that's one example of how we would move a character right 20 pixels. Now we get to the good part where we're actually writing the code for update player. So write a function called update player, which takes in the player's X coordinate, Y coordinate, and name of the arrow key pressed, and returns the new X coordinate and Y coordinate. So the contract, the name of the function is update player, and it says there's 3 inputs. It says it takes in the player's X coordinate, that's a number, Y coordinate, that's a number, and name of the arrow key pressed. That's going to be a string. And it produces a new X coordinate, that's a number, and Y coordinate, that's a number. The purpose statement is written here. We need 8 examples here, 2 for up, 2 for down, 2 for right, 2 for left. So I'll do 2 for you, and then you should be able to do the rest on your own. When we have update player 128, 250, and we press the up key, we want the 128 to stay 128, and we want the Y, which is 250, to have 20 added to it. Let's do the first right one. When we have 128, 250, and we hit right, we want the 128 to increase by 20, and we want the 250 to stay the same. I'll be back in another short video to finish up this pattern.